We want to solve sine 3x equals square root 2 over 2 on the interval from 0 to 2 pi. First of all, let's just think about this as theta for a minute. Sine theta equals square root 2 over 2. So where between 0 and 2 pi does the sine equal square root 2 over 2? Well, if we think of this, we know at pi fourths that would be true. And the sign is also positive in quadrant 2 at the multiple, so 3 pi fourths. So theta equals pi fourths, or theta equals 3 pi fourths. Now that would be our answer if it was theta, but it's not theta, it's 3x. And by having the 3 in front of it, we're going to end up, when we solve this, dividing by 3, and what it means basically is on one loop around the circle from 0 to 2 pi, there's going to be 3 times as many answers, or there's going to be 6 answers. So one of the ways we can find them is, let's figure out theta was pi fourths, and if we add 2 pi k, this will give us all solutions. And now what we're going to do is we're going to put back in what theta equaled. It equaled 3x. So then that equals pi fourths plus 2 pi k. And 3x down here equals 3 pi fourths plus 2 pi k. Now to solve this for x, we would need to divide everything by 3. And that's going to make a 3 there and a 3 there. So that's going to be pi twelfths plus 2 pi thirds k. That would give us all solutions that would come from that first one. And that's more than on the 0 to 2 pi, but we're going to find 3 of them from here, and then 3 of them from the second. We'll have all 6 that would be on the loop from 0 to 2 pi. So down here with the second one, we're going to divide by 3, and that would actually be pi fourths plus 2 pi thirds k. So now we just want the ones that are going to be between 0 and 2 pi. So the first one is when x is pi twelfths, and the second one would be when x is pi fourths. That would be when our k's are 0. Now let's figure out, actually let's go ahead and make this into twelfths, because it will make it so we can easily add that. That's going to be 8 pi twelfths k. So pi twelfths plus 8 pi twelfths would be 9 pi twelfths. I'm going to write it above because I'm going to reduce it. 9 pi twelfths, and that would be 3 pi fourths. So that's my third solution. Now coming down and looking at this one, letting k be 1, we're going to make this back into twelfths so we have a common denominator. And when we add here, we're going to be adding 8 pi twelfths k. So 8 and 3 is 11, so 11 pi twelfths would be our fourth solution. Going back to this first one then and letting k be 2, we're going to add 8 pi twelfths 2 times, so 16, and one more pi is 17 pi twelfths. And notice 17 pi twelfths is still between 0 and 2 pi, because 24 pi twelfths is 2 pi. So that's still there. We've got 1, 2, 3, 4, 5 of them. Going back to the second solution now and letting the k be 2, so we're going to add 16 pi twelfths to the 3, and we're going to get 19 pi twelfths. And there are our 6 solutions. Now if you hadn't been counting or realized there was 6, if you went back up and let k be 3, if you added here 24 pi twelfths, that is 2 pi, and when you add pi twelfths to it, 25 pi twelfths is not between 0 and 2 pi. So typically, unless you're on a quadrantal, have a quadrantal angle, you're going to get 2 solutions if you have x equals something and you want between 0 and 2 pi. And then if there is a coefficient on the x, that's going to multiply by how many solutions you're going to get. So if you would have gotten 2, now there will be 6. If that was a 2x in front of it, we would expect 4 solutions, and so forth.